So number 8, be able to predict what is happening at each electrode during electrolysis, oxidation, or reduction, and which way the electrons are flowing and which ions are moving where. Electrolysis uses electricity to force a redox process. It's often to recover a highly reactive metal that wouldn't normally be purified by placing it with another metal because it's the more reactive metal. Remember, a voltaic cell is just the opposite. It uses a redox reaction to produce electricity. So with electrolysis, if we draw a quick sketch here, NaCl is an easy one to look at, but it can be any ionic compound, a metal and a nonmetal. And what you're going to have is you're going to have your power source, and it doesn't matter which side the negative and the positive is on, but you have to recognize that this is the negative side and this is the positive. The shorter is the negative, the longer is the positive. The way I remember it is the negative, that's the negative sign, and this one you'd have to split in half to make the plus sign out of. Kind of lame, but it works. So at the negative side then, if I have NaCl in here, it'll be molten or liquid, which will be the same effect as if it were aqueous. It means that the Na and Cl ions are separate and able to move on their own. And so when I look at this, it's easy for me to realize the Na is going to be attracted to the minus and the Cl is going to be attracted to the plus. So at the negative electrode, I've got Na plus. At the positive electrode, I've got Cl minus. Well, that means Na plus is going to gain an electron to become solid sodium. And that lets me know that that is reduction going on. Whereas the Cl minus is going to give up an electron to form Cl2 plus. So it's actually be 2 Cl at a time, giving up 2 electrons at a time, which is oxidation. So the cathode, I know, is always where oxidation takes place. So now the cathode is the positive electrode, or in this case, the chlorine, and the anode is the negative electrode. I'm sorry, I got that backwards here. The anode is where oxidation takes place. So that's going to be the positive electrode because oxidation is occurring. And the cathode is where reduction occurs, which in electrolysis is going to be the negative electrode. And so the electrons flow from the negative electrode to the positive electrode. And then they also ask about the ions because you've got positive and negative ions. The positive ions, the Na plus, flow to the negative or cathode, and the negative ions flow to the Cl minus flows to the positive electrode, or in this case, the anode. And then the components. The components you have to include for electrolysis is you have to have both ions. You have to have a positive electrode and a negative electrode, and they should both be labeled. You have to have a power source, and if you use the universal symbol, that labels which side's negative and which one's positive. And then you have to show one cell with the electrolyte, which is just electrolyte, just a fancy name for ions, which we've already indicated as the Na and Cl. So what's different from the voltaic cell is there's only one cell instead of two. You have a voltmeter instead of a power source because in a voltaic cell you're creating it and you're measuring the amount of electricity or voltage you're creating. And there's no need for a salt bridge here. One thing I should have mentioned on the voltaic cell then is the ions flow to the same. Here, the positive ion flows to the negative ion flows to the positive. In a salt bridge, the positive ions flow toward the positive end and the negative ions flow toward the negative end to replenish those as they're being taken out, because at the positive end, positive ions are being reduced, and at the negative end, uh, metal is being oxidized, and so they flow to the same toward the same charge, which again is the opposite of an electrolytic cell.